started. I think 2 more minutes or so, but it's quiet, so we'll get started. My name is Jarret. Hey guys, great, thank you so much. That's why I built this in an IPython notebook. Is like Python notebook allows me to write code and that you guys submit, and we can play around with this all. But that you said hi means that you're ready. Okay, great. I work at a company called Empire Capital Holdings. It's a real estate company, a real estate brokerage company that it was founded by a guy, Josh Ramani, and every year it does something else because the market is so cutting edge, and there's so much money at stake that anything that worked in 2011 doesn't work in 2012, doesn't work in 2013, doesn't work in 2014. So this company has been making fairly large revenue from brokerage services for about 11 years now. And each year it does something else. So finally, 11 years into doing something else, Josh, who's the person I work for, decided let's do something so extraordinary that we're not going to be changing what we do every year. And what that is developing a think tank inside of the real estate brokerage company called Think Empire, with the idea of quantifying disequilibria, starting with the real estate market and broadening to other markets, developing very broad models of consciousness and applying it in economic models and social networks. Right now, we're definitely looking for talent in that respect. Python developers, neuroscientists, physicists, psychologists, anything that factors into the big big picture. So this is David's email. He's the head of HR, and my name up there. So if anything, I'm very accessible. So after the talk, come talk to me, or I'll come up to you. So I'll start with that. Is that what I started doing there was developing a framework where we can extract information from different data sources and build on top of it a layer of inference, and then build on top of it another layer of inference, and then build on top of that another layer of inference, and then build on top of, say, 3 inference sets, a 4th inference set that goes a bit deeper. And so what I've extracted is a method of learning, a method of achieving higher states of knowledge, higher states of understanding of the market and social behavior in an iterative fashion. So what it allows someone to do is, say, have a developer work on the lowest level, which is developing new pipelines of data sources, a researcher, a scientist sitting above that, porting into these different information sets and developing an inference set, and then someone sitting on top of all that with a background in optimization, kind of thinking about the system as a whole and how it corrects itself, and then developing another inference set on top of that. So this framework works really well for websites that gather information from other websites. So I'm going to talk about that broad framework, which is a valuable proposition for a new company. There's so many companies out there, so many websites that have tons of views because they take information from another site, they change the format, they sum something, they add something else, and they display it again. This is like a news aggregation site. So this framework would apply very well. Is the information sets underlying it would be all news sources, news information related to X from New York Times. Another information set would be all articles related to X from the Washington Post. And those are the bases. And then an inference set would take each news outlet and infer the most popular, or the most important aspects of each article, and then build that into a model of, say, a model of political economy would be the highest level, and that's the idea. So Think Empire uses tons of different resources. The basis is a systems theoretic model of human behavior. Okay. So we'll start in with the Python. I really like this. This is not a title. It's not like a This is actually, if you type "what is complexity?" into Python, it says object complexity not found. Which really starts the question, is that what I'm defining as a complex basic app is a simple application that collects information from other places, aggregates it, makes some inference, and returns the information. The example we're going to be using at the end of this presentation is a website called PlyCount. Show of hands, how many people play chess? Yeah, okay. Anyone can play competitive chess? Chess.com? Okay. So PlyCount is a way for competitive chess players to find the ratings of other competitive chess players or their own rating and track it over time. And the website, all it does is scrape information from the USCF, the US Chess Federation, display it in a nice front end that doesn't look like it was made in 1999, and that's a website. And it gets millions of views, and they're able to leverage all the people that use PlyCount. In fact, they're now creating hardware. So if a Python developer, say, has these tools and is thinking about a startup or something in this space, this framework is a good way of having an idea, building it, and then maybe leveraging a large user base into the next idea. So the whole pipeline is, which I guess isn't really anywhere here, but the pipeline is, it's Flask plus Beautiful Soup plus requests plus these information classes. And then Flask uses Jinja. So that's the final. That's I guess all the levels of it. And there could be 5 people with different skill sets all working on the same application. Someone who has a knowledge of Flask could be developing the front end with a knowledge of Jinja. Someone else could be, say, thinking theoretically about what sources should be added to the website. Someone else could be using the information classes and going a step beyond. So we're going to drill down and focus on a website that does only 3 things. This is the most basic Flask application. Is it searches, the user goes to the website and searches for something. And then in the back end, it does all the magic, and the user is presented with something. Kind of a broad outline of web applications. So on Flask, this is not doing much. There's really 3 pages, which is a information page, / information, / or search page, and then a waiting page. So without getting to the code, I feel as if I didn't explain enough before getting into the code. Is that correct, or should I start going into it? Yeah, I'm going to explain a little bit more. Okay, facing the blank stares. Okay, so PlyCount is a website that allows someone to find their USCF ratings. So the user goes on, they type in their USCF ID. Okay, and the back end processes all the information, and then they get back a simple page. So what's actually going on is Flask is aggregating information across the USCF website or the FIDA website and spitting that information back to them. Okay. Okay, so the Flask aspect of this is very simple. Flask makes it pretty easy to make lightweight applications as opposed to Django, which makes it hard to make something simple because it comes with so many things out of the bag. So in this simple application where the user is searching for something and they're getting something back, the Flask script looks pretty basic. It says import Flask, make the Flask app. The first line says make the search box, the search page, define it as search, import a form from somewhere else. If the form was submitted, add the search information to a database, which is called toSearch. and then it sends it to the waiting page, and then it runs. Yeah, definitely. Oh, much better. Thank you. Okay, much better. Okay, so render a form. If the form's submitted, save the information as a new search. And then in the back end, there's a script running called waiter that says, just sit there. And when someone searches something, call up all the scripts running in the backside. And actually go to the USCF website and gather and web scrape their information live. So there's no database for this. The only database that we're using is to store the results once they're found, and to store the searches once the searches are committed, or once someone types in the search. And the waiting page is, say, JavaScript that says every 5 seconds, hit refresh. When there's something in the database that looks like the right result, call up all that information. So now we've pushed this simple app down into really one thing. Is that up here, it's, say, 10 lines of code, and the boilerplate is maybe another 20 lines of code. So in 30 lines of code, we have a piece of software that is taking user input over the web and executing a script based on that information. And the script part is where all the fun comes in. So that's what I call the get and process information script, and it's the real workhorse of anything, of any application. Okay, so here are a few examples of what get and process information functions look like. Abstracting away everything else that a website does is, in the case of Google, when someone hits submit, the get and process information function would go through their databases, query information, and return 1 million results in 0.2 seconds. FlyCount is the site that this example is based on. What they do is they go to the USCF website, they gather all the information, and they format it in a nice way and return it. Given a user's name, search the USCF database for that player's recent games, process information to make finding what that user is looking for easier, and infer some useful winning statistics and display the results. So I guess let me take a quick break and ask the audience, or ask everyone, what is your familiarity with Flask? So raise your hand if all of this is like so easy. Okay, about half of you. Okay, raise your hand if you've heard of Flask, but you might have used Django before. Okay. Okay, great. And how about with MongoDB? Any? Yeah. So any use of MongoDB? This uses MongoDB in the background. I found it to be much easier than using a SQL-based database system. Sorry, I didn't mean to put everyone on the spot. It's just from my perspective, I don't know how much detail to go into. Because if I look across the room, I see some people that are like kind of excited about this, and some people that are like, yeah, this is so simple. And I know it's so simple, and that's why it's being, I'm trying to explain it in this way, and then we'll take it and we'll go a little bit further. So really, the whole idea is to push the work of an application deep down into the back end, into a Python script that no one else sees. Yeah. Jinja is the templating. The question was, what does Jinja do? Jinja is an out-of-the-box template engine that comes with Flask. So Flask, it's possible to abstract away HTML, like recurring HTML queries, HTML tags, and write HTML code that make it easy to do that operation over and over again. So in an example, Jinja 2 allows someone to would render a template based on user submitted information, easy to use way is that if I wanted to render an HTML, say I submit to my HTML the data dictionary. Data is a dictionary that returned the getInProcess function. Returns request. And now I render this as a template. Inside the HTML, I could call information inside the data object just by doing this. So this would, inside the HTML, this would take the username based on the data dictionary and send back, this page would say, hi, I am Jarret, welcome back. And if someone else requested the web page, it would render it differently based on their request. So Jinja 2 makes it easy for someone to connect a web framework with someone with HTML knowledge can then start, it sort of brings it closer. As in someone with HTML with front end can also start helping the back end. Okay. This is the ply count page that's easy to replicate. It's a nicely formatted web page that takes information from the US Chess Federation. It's got like a cool logo. It's got little graphics, big font. It has a nice rating graph over here, which is really, really pretty. It tells me the number of tournaments I've played in. Versus, this is the USCF homepage. Okay, so there's a lot of information here. It's not really clear how many tournaments I've played in or what's my rating been, if it's going up, if it's going down. So someone took the USCF website and just basically made another version of it and called it ply count, and it does the job well. This is another. Oh, so this is looking at all my tournament history on the USCF page. So again, it's kind of hard to read on the USCF page, while ply count is nice and easy. Okay, so now I want to get into the sort of the theoretical foundations of all this. And the idea is how to make this website in such a way that it can get iteratively more complicated. Which means we don't want anything to be hard coded. We don't want we don't want we want many people to be able to work on the website, so we don't want anything that's hard. We don't want any hard names to find. So the database behind should be nice and easy to work with. And the information is easy to work with. Okay. So in this case of this ply count website, what we want is some information set that for any given user, we collect all of their tournament history, their rating history, the opponents they played, and we collect it in a nice Python Python dictionary, and then we infer some information on it, which would be a simple sum, and we present that information later on in a Jinja template. This model, there could be tons of things going on. Is that we could have information from the USCF website, information from FIDA, and when we put it all together, we could be trying to match different tournaments that were both FIDA rated and USCF rated. FIDA is the chess federation in Europe. USCF is the chess federation in the US. Some tournaments are cross rated. As far as I know, no website tries to scrape information from both FIDA and USCF. And in the end, we're left with these nice, easy-to-use dictionaries. So for the USCF dictionary, it's going to be a dictionary object that contains a list of all tournaments. And then the inferred information set, the inference set, is going to be just a dictionary with the term number of tournaments calculated based on the sum. So in the back end, it's really nice to work with something that is named. So these information sets are simply named dictionaries. Information set, a dictionary that takes a name and a collection of arguments and returns this information set, or returns the dictionary. And these are two examples for USCF and FIDA. That for USCF, it would be a list of tournaments. For FIDA, it would be another list of tournaments. OK, so this is all really basic. And if we were going to do this in real life, we would have USCF equals an information set called USCF, which was calling a piece of software or another script called web scrape tournament information. And FIDA would be the same. And now, just to be clear, all this code sitting in the back end is sitting inside of the get and process information function. So how the website becomes complex when it collects information from other places and builds on it. So the collections is where it all starts getting, where the pieces start coming together. We're going to be defining three things inside of this discussion: an information set, a collection of information sets, and an inference set. Broadly, information sets are just named dictionaries. Collections are collections of dictionaries. Inference sets are collections of dictionaries that also do other things, as in they have a good naming convention. So when we access information in the back end, we're not calling a dictionary all the time. Inference sets also can process information. So inside of an object, we can run, inside of an inference set, we can run a process function on it, which may be called sum tournaments. So all this code that I'm writing right here is something that when this app is up and running, the developer would be able to do commands just as easily as this. Is that in the back end, they would be sort of the whole pipeline would be develop a web scrape script called web scrape something, feed it into an information set, name an inference set off that, develop a process function, which creates inferences from an information set, and then save it again as an inference set. So collections are simply collections of dictionaries. This is, anyone who's not familiar with building your own classes, is that this is a class that I'm naming as collection. It's an extension of the dictionary class. When I initiate it, I'm rewriting the init command inside of a class and initiating a dict object, which is the same as what it's superseding. When I initiate it, I'm calling the init object of the dict object, the init function of the dict object, and sliding the inputs that the user submitted right in there. And then I'm also doing one other thing. So if I had erased this line, then the class collection would just simply be a dictionary. But that I'm doing one more thing, is that I'm saving inside of the dictionary a list of the original keys that are submitted there. So in this case, I have these two inference sets, and actually I have to run all this because I haven't run it. Okay, sorry about this. Information set, run, USCF as an information set, FIDA as an information set, and now I'm defining this collection. I'm collecting USCF and FIDA into one object to be used for inference. Now let's look at this object. It looks like a dictionary. But what's different about it? Well, collection has an attribute called original, which are the names of the two information sets that I've submitted there. And this becomes important when I want to differentiate between the new inferred information and the information that started, the base information. And I can access information deep down exactly like I'm accessing information from a dictionary of dictionaries. So FIDA is a name. It's called collection. It is another dictionary that has tournaments in there, with a list of tournaments. Okay. So this is all very simple. But we also wanted to do other things. This type of behavior becomes unruly when we're doing it over and over again, in that this is very clearly a dictionary of dictionaries. But wouldn't it be really cool if instead of doing this, we could access information inside of this object with a dash? So instead of it a dictionary, it's now a dictionary, a flattened dictionary with a hyphen standing in for the levels of differentiation. So that's what this does. The two items, the two functions that are added here, and we'll go through it slowly, make it possible to retrieve information from this collection dictionary in a different way. So I'm defining this, replacing the getItem function of the dictionary. If there's a key inside of the word that I submitted, split along the key, use the first as the object source, and use the second as the name. Return information from the source with the name or none. And if key doesn't have dash, then just return the original object. Flatten is, instead of a dictionary of dictionaries, we just want a dictionary. So what flatten does is collect in the first instance, it collects all the keys that were in the original data set. It makes them into a single dictionary and makes it into a single dictionary as with each input with a hyphen instead of using a nested and having a nested list. Okay. So now I can access information with just the hyphen, feed it tournaments. This all goes back to Jinja, is that when I'm inside of the template, which is the end use of all this stuff, instead of writing code like, instead of writing something like this, I can write it simply as one nested, as I can combine it into one word. And there's actually a higher level of abstractions that are possible. I can, since I'm writing my own dictionary, my own object, it's possible here to do something with error handling. As in, if the developer designing the front end makes a request that is actually not part of this object, what to do with it. This can all be built in. And flatten returns a dictionary. While the collection object before is an object collection. So inference sets are named collections. In this example, we're creating a new inference set called NumTournaments, which is an inference set that builds off the feeded datasets and the USCF datasets. And now we have the inference set. Okay. So someone who's just starting out in all this may not realize the importance of proper database management when these projects start to scale. Because if something's scraped together just in one document, and it's a project that takes a day, which is what some web scraping projects are. They take a few days to scrape information, and the information is saved in a CSV or a data frame, and it's possible to manipulate that information and be done with it. But on projects that are going to scale and they're going to get bigger, it's really important to step back and design a system that can scale with the information. In this example, it's designing a ply count that can later on take information from maybe even chess.com. If the user has a chess.com rating, it can pull that information in there. It would be like designing a system that doesn't break when another Facebook comes out, and the user has both a Google Plus handle, a Facebook handle, a Twitter handle, and now they have something new, and the website has to adapt very quickly to what's new. So the last piece of the puzzle are process functions, which can get as abstract as a developer wants. They act on an inference set and take it from a boring collection of information that other people have to a collection of information that is new and exciting. So in this example, it would be the sum function. It would sum over all tournaments and return NumTournaments with a number next to it. Process functions always take inference set as their input, which makes it's possible to have like nice clean code as this code base develops. They always take an inference set. Inference sets are collection objects, are dictionaries. So when we interact with that information, we know the behavior. So what we're doing is creating a copy of USCF tournaments, which is the USCF tournaments inference set. We're creating a copy of the fetus set, and then we're adding the length of these two databases, these two lists together, returning a dictionary object, which is the number of tournaments and the sum. Pretty basic. But doing it at the scale of a web app is more complicated. And this actually is all that plycount's doing, and plycount has all their users. Okay. So NumTournaments by itself is just an inference set. The way that we add information to this dictionary is through update, the update command. This says take the NumTournaments object, update it with new information from the process function. Okay, and now we have FIDA, USCF, and number of tournaments in our inference set. But since this behavior right here is repetitive and bulky, we can pull this inside of the function. So add to object. Ideally, we'd interact with these objects not by using the update command, but by using something that we've developed ourselves. So we just say process, and then we pass a function. And it would know how to apply it, and it would just work. Okay. So in this is we're adding a bit more to the inference set. We're now adding the process function. Process says if the input is blank, don't do anything. If it is blank, if it's not blank, then call the function which is the input and add its results to the inference set. And then ultimately, we're writing these to a database. So in MongoDB, that would be like writing db collection.insert inference set. And if we do this, we're both adding all the new information and the old information. Since USCF and FIDA are both an element of inference set. So what we want to do is only add the new information. So in this next stage, we append to the inference set object another function called Inferred, which is only the new information we added. So now we run the new inference set, we process it, and we get back only NumTournaments, as opposed to running it normally, where we get both back all the feed information, all the USCF information, and then we get back what we also, the inference that we made on the data set. So having the inferred function keeps us from saving the information 2 or 3 times in a database. All right, any questions? Yeah? Okay. Here's why that wouldn't work, is that I don't know when I make the object what the object's going to look like. As in, information sets are so abstract that any piece of information I submit gets there and gets saved. So in this case, if this was just being designed for 2 data sources, then the information set could have hard coded in there information set dot USCF saves as a dictionary, information set dot FIDA saves as a dictionary. But we want it to be an abstract method of information, an abstract system of information. Yeah. Okay, so that also works. Oh, all the infrastructure of pandas. Yeah. Yeah. This may be doing something similar to what pandas does. But I don't think pandas, if you wanted to make this into pandas, you would have to add the flatten function to the pandas data frame. Also add the inferred set to it as well. There's many other ways to do this. And in fact, when I started looking at this, I did originally have some of this information in pandas data frames. The reason this whole framework developed was to deal with things that may not fit very well into pandas. In data analysis, getting something into a pandas data frame is 90% of the work. Once it's in a pandas data frame, then analysis is pretty easy. So there are cases where it's actually difficult to make it information or get information into the right format. While getting it into Python is almost analogous to getting it into a dictionary object. So the idea is to cut down on that work, cut down on that workload. Yes? No. The question is, will you ever update the information set? And the answer is no, is that you use these blocks and then build off them. So the information set would just sit there and become part of an inference set, which will become part of another inference set, which will become part of another inference set. Yes, yeah, exactly. So the information sets are run whenever someone makes a call to the website. So let me go through an example. About the pandas data frame is that there are definitely other ways of formulating this. But I think when someone's starting out on a web scraping project, it's easy to just do quick solutions to problems and not get into the big issue, which is dealing with information and making it easy to use. That's what this is about, is developing a system that a few developers could work on. And people could work on this with different levels of expertise. Someone who's good at Beautiful Soup could work on information sets. Someone else could work on inference sets. And the code that comes out is human readable. It says USCF, information sets, NumTournaments, inference set, and it's very clear what's going on. OK, this is the example we're going to go through. It's called PyCount. It's like PyCount, but written in Python. For a given user's USCF rating, it's going to collect all the user's information from the USCF website. Then it's going to save it into an information set, calculate the number of tournaments, and the user's best tournaments. This, actually, the code doesn't do. So this is homework. And then it combines it with a Flask front end. OK? So the first part is the Beautiful Soup script using requests that takes as input the user's USCF ID. So there's some weird things in this code, because when I go through the USCF script, the USCF website, for some reason I get 4 copies of the information that I need. So I just simply said, wait, where did I do that? OK, actually, I get 5 copies. So this is web scraping is very specific art, and it requires going to the actual website and figuring out exactly how to do it. There's no way to get around that. So doing this code is specific to the USCF website. And what it does is that when someone puts in their USCF ID, it returns a dictionary objects, a data frame of their past tournaments. So and now, there we go. Okay. So instead of going through the specifics of this code, because it'll change from each use case, I'll go through the different objects that I'm using. Request is the Python library for sending GET requests or POST requests. The USCF site has a nice handle on their domain. So it's possible to just send, if I access that, I get each person's USCF page. I feed that into the Beautiful Soup object. Beautiful Soup has a function findAll, which takes this string and looks for tags that begin with that string. And it's even possible to do, so say A in here, instead of tr would return all links. If the table row, go to the table row. If the table row has the right color, if it's formatted in the right way, that's where the information lives. So then loop through all the tournament columns, call it an event, save all the information in a dictionary. And then write that to a data frame. So now each person with their USCF ID, we now have a data frame that has the date of the tournament, information on where the tournament was played, and the ID of the user who submitted the request and played in the tournament. Okay. Basic statistics. There's 79 tournaments. We're trying to get back the 69 number, so the 79 number that pandas does very easily. Okay, so now we're going to feed this all into our framework. Let's make an information set called USCF, which is named USCF, is all caps, which is a dictionary, contains a dictionary object of tournaments that someone has played in. Okay. Here is our information set. And now we're writing the process function. So this would live inside of a, say, process.py. Okay. Count tournaments. We feed that into an inference set named NumTournaments. The convention that I'm using is a capital N, capital first letter, first word, capital the second word whenever it's an inference set. This inference set is going to build off the USCF set. We know that from everything that's here. Now we process it, and we can read this as NumTournaments, the inference set we've defined above, is being processed by the countTournament function. And we're left with a dictionary object, which is just the number of tournaments that a user's played in. All right, so as a side project, well, you can open it up for any questions. I thought if people were following around on their own devices, they could take a shot at modifying this Beautiful Soup object, this Beautiful Soup function, to collect the rating changes. So that this has two more columns, being pre-rating and post-rating. And then it infers there'd be a new inference set defined as best tournament, which would be an inference set off the USCF dataset. The USCF dataset. Information set. And it would execute some function called get best tournament. Get best tournament would just look over the data frame, look for the biggest difference between pre and post ratings, and return that tournament. So probably the best use of this was just developed in the past 30 seconds. That I went from proposing an idea of something new to do to already having the skeleton code to do it and knowing what functions have to be written and what they have to do. All right. That's everything I have prepared. Thank you, everyone. And any questions would be welcome.